So in this lecture, we're going to explain how to grade a terrace. This is your first grading exercise. You may want to watch this video a couple of times to understand it. We're going to explain it both on paper and in AutoCAD, although we know that you will be doing the work in AutoCAD. Please take a look at all of the slides in the video because we think it's all going to be very helpful to you. We're going to go through 7 different steps to help you understand how to do this assignment, and we'll be taking them one at a time. To begin with, you should know that we have provided you an AutoCAD base map. You do not have to redraft this in AutoCAD. We have given you a base map. It does come with the site already set up, and it also is set up for you to plot. So if you look down here in the corner, you can see there are actually 3 different windows set up for paper space so that you can use each of those for plotting your design. What you will do is you will create layers as you did before. You'll create 1 layer for cut, 1 layer for fill, and 1 layer for balance. Then when you move over to paper space, you want to make sure that the correct layer is turned on. So in this case, we have the cut plan. So you want to make sure that your cut layer is turned on and that your fill layer or your balance layer are turned off or frozen. You will still be responsible for importing or setting up all the layers that you need for this drawing. The first step that you're going to do is you're going to set the terrace elevation. And to determine the terrace elevation, you're simply going to look at exercise. And so you can see here in yellow, when you're doing the cut version of this, you will set your elevation at 23.5 feet. And then when you get to the fill or the balance, you will set them according to what is specified in the assignment. We will not be setting those in this example because this is something you will need to do in your exercise. So here in a paper example, we've set the elevation at 18.5. We've also set the spot elevations on the corner of the terrace at the same 18.5. So each of these corners are representing the inside of a terrace. This is a terrace, this is not a building. So remember, as we go through the course, do not set the elevations for the corner outside the building on the building itself. This is a terrace, this is probably a paved surface. These are the spot elevations and how you would represent them both on paper and in AutoCAD. And this represents a completely flat pavement surface. So we can imagine this is some sort of pavement that allows water to flow through and not simply flow. So once we've set the elevation of the terrace, and in this case, your elevations are given to you in the assignment, we need to figure out what are the requirements to get the contours correctly around the terrace. And for this, we need to ask ourselves a few questions. What do we know? What do we need to find out? And then, of course, how do we locate the contours on the plan? And we're going to go through all of those steps with you. The most important thing you need to know for this exercise is that the maximum slope that you're allowed is a 5-to-1 ratio or a 20% slope. This is what you're going to use to determine how far you spread the contours away from the terrace and up or down the slopes. So that 20% slope is the critical piece of information that we need to locate our 1-foot contours. So what do we know? We know the elevation of the terrace. We know the slope moving away from the terrace. What do we need to find out? We need to find out how far apart we have to space those contours, and of course, how do we locate those contours on the plan? So to determine the contour spacing around the plan, we're simply going to use the slope ratio and or the slope formula. You've already used the slope formula in your previous exercise to determine how far apart contours can be, what the slope is on an existing site, and we're going to show you in more detail how that's going to work for this assignment. So we're going to take a moment here to talk about what slope means. It's actually a very simple concept, but it's important that you understand it early in this class. So here we have a triangle that simply represents a 20% slope. What that means, a 20% slope is nothing more than 20 foot of vertical elevation change over 100 feet. So what that means is for every 100 feet horizontally, we go up or down 20 feet. That is all it means to have a 20% slope. So if we do some simple math and eliminate a couple of decimal points or zeros, we can also look at this and recognize that a 20% slope also means that for 10 feet horizontally, we're only going up or down 2 feet. So if it was 200 feet horizontally, we'd be going up and down 20 feet, but because it is only 10 feet, we're going up and down 2 feet. And if we zoom in a little further on the triangle, we can actually use the same math to figure out what happens if we want to go up or down 1 foot. Remember, we're talking about putting in 1 foot contours. So what this means is that 1 foot contours, that is a vertical change in elevation of 1 foot, is going to equate to 5 feet horizontally. So what that means is that if you want to represent a 20% slope using 1 foot contours, those contours are going to need to be 5 feet apart. We're going to go over this a lot in class, but this is a basic principle that you're going to need to be able to understand and visualize in order to do grading. And of course, you can also come to the exact same conclusion simply using the slope formula. That is horizontal under vertical gives you the gradient. In this case, with a little bit of algebra, we still come out with a 5 foot horizontal spacing for a 20% grade for 1 foot contours. And so this understanding of slope and contour spacing is what you're going to use to set the distance for your first contour going around this terrace. So we're going to use that slope knowledge to figure out how far away the first contour will be around this terrace. In this example, we're talking about a terrace that is going to be built in cut. Because of that, we are looking for the next contour above 18.5. Notice that it is 18.5 for the elevation of the terrace. It's not 18, it's not 19, it's 18.5. So if we were going to go uphill from 18.5, the next contour we're going to be looking for is 19. So we actually want to know, to get to 19 as a horizontal distance, the vertical difference between 18.5 and 19 is 1/2 of a foot. So we're actually going to do the calculations for going up 1/2 of a foot. We will not be going up a full foot here, only a 1/2 a foot. Now, because you know from the previous slides that if you were to go up or down a full foot, you'd be going horizontally 5 feet. And of course, you can also do the math and determine the exact same thing. The horizontal distance we're going to be looking for away from the corners is going to be 1/2 of 5, or otherwise 2.5 feet. In AutoCAD, the math is exactly the same, but the way that we determine 2.5 feet in AutoCAD is simply to use the offset command. So we can take our terrace outline and we can offset 2.5 feet, and it will give us a line around the terrace that is exactly 2.5 feet away from the edge. So once we have set the distance for that first contour, which is simply going up 1/2 a foot, we now want to set the distance for the rest of the contours. The rest of the contours are going to be whole contours, that is 1 foot contours. We already know from previous slide that at 20%, a 1 foot contour difference is going to be 5 feet away horizontally. And again, of course, we can look at the math and we can see that we now need to offset 5 feet as we go up the hill. Although we did first 2.5 feet, we're now going to do 5 feet as we go up the hill. We'll put our tick marks there for our contours. And here zoomed in, you can see a little more clearly what we're talking about. We have a mark for the first contour distance, and then for the rest of the contours, as they are marching up the hill. We will then want to simply draw parallel lines around the terrace representing each of these contours as we go up. Again, the 19 would be the first one, but we're starting at 18.5. If we were doing the other way, where we're pushing down the hill and doing a hill, we'd be looking for the 18 next. But remember, we're in cut, so we're going uphill. So from 18.5, we're looking for the 19 contour, which would be 2.5 feet away, and then 5 feet away for the rest of them, for the 20, the 21, the 22, 23. And you'll just sketch these in for now as reference. That doesn't mean that this is exactly where they're going to start or end. This is simply the spacing that we need to have for these contours when we're doing this in cut. And in AutoCAD, the process is really the same. We offset the first one 2.5 feet, and then we take that contour and continue to offset at 5-foot spacing until we have these parallel lines running all the way around the terrace. Once we have these contour guidelines offset, we then start the process of connecting the proposed contours to the existing contours. So we can see here, this is the existing 19, and this is the proposed 19. So we'll actually trim the proposed 19 off where it meets the existing 19. We'll do the same thing with the 20, where the proposed 20 wraps around and touches the existing 20. We'll trim it off there for now, and for the 21 and for the 22. So all of the lines that were here before are now being trimmed off, and we're only keeping the lines to represent the location of the new proposed contours. In AutoCAD, the process is exactly the same. We simply use the trim command. We select the existing contour, and then we trim off the proposed contour where it meets the existing contour. Same for the next contour as we go up the hill, the next, and the next, and the next, until these are all trimmed. This, of course, is not the final configuration. This is just trimming the contours so we can understand which of the existing contours will connect to which of the proposed contours. The next step is to refine the contours, because contours don't end in sharp corners. So we have to round these contours out. We round them where they connect to the existing. We add our tick marks. We can round them around the corners. Remember, we have to stay 2.5 feet away as we run this around the corner, and then we round it back to the existing contour. You could easily see that we could take this 19 and run it all the way back in front and then turn it, but we've chosen to simply connect it this way. This is something that often gets students confused. They want to know, well, which is the right way? And there is no right way. This is a design question. If you wish to wrap it around and then connect, you could. It is simply a simpler, cleaner design to not wrap that back around. Likewise, students try to get an official answer on what size this radius needs to be. And again, that's an artistic thing and part of the design process. You will get to choose that as you're doing the design. However, you do have to blend it back in to the existing contour, and you do have to add the tick marks in. The process in AutoCAD is really pretty much the same. So in AutoCAD, you can see that the same technique is used. Now, this is not complete. We have not added in the tick marks, and there are a lot of things that also have not been added in. You'll see in this drawing, I have not added in the elevation of the terrace. I have not added in the spot elevations. I have not labeled the contours. I haven't put the tick marks in. I haven't labeled either the existing or the proposed contours. All of these things are things that you have to do, and this is simply an example. I'm not even suggesting that the example that I'm showing you is the correct solution for your exercise. We're simply showing you the process, and you're going to work this out on your own with our help and with the help of the TAs for the AutoCAD portions of it. So again, you're responsible for including the legend, the north arrow, the title block, all of the spot elevations, the proper text, the text that is then masked, all of the things that are required for a grading plan. If you have trouble remembering what's required for a grading plan, go back and look at the exercise where we're having you trace an existing grading plan, or simply ask us in class or ask the TAs. So these 7 steps are the process you're going to go through for this exercise. Again, I suggest that you look at this video a couple of times, get started on this, and then we will meet with you in class to discuss questions and issues that you're having.